You can apply electrolysis for electroplating. Electroplating. What is electroplating? It's like later on you do galvanization, which is electroplating iron. Or you have a spoon, you want to make a silver spoon, that is electroplating. Or you have a copper keychain, that is electroplating. Or you have a golden pen, that is electroplating. Right. So again, the idea of metal in its aqueous solution. So now I have a spoon. I want to electroplate the spoon with silver. So what is my anode? Amiro, what is my anode? The spoon is
silver.
Remember the concept now?
Spoon is
Anode, cathode, cathode, deposited. You want the silver to be deposited on the spoon. So the spoon has to be your cathode or your anode, Amiro?
Anode. Anode.
Okay, take a deep breath. Breathe in, breathe out. Okay. When you have metal in its aqueous solution, anode will corrode. Cathode will be deposited, meaning the metal will be deposited at the cathode. Now you want to electroplate a spoon. So should the spoon be the anode or the cathode?
Cathode.
The cathode, yes, good. Understand? Anode,
Yes.
corrode, cathode, deposited. Ingat tu je, make it your mantra. Okay? So this is your cathode, this is your anode. It has to be, you want to electroplate the spoon with silver. So therefore, this has to be silver. And this has to be aqueous solution of silver. So this has to be silver nitrate aqueous or silver sulfate aqueous. You get it? If you want to electroplate, okay, try again. I have a keychain. I want to electroplate my keychain with copper. So now what is my anode, what is my cathode, and what is my electrolyte, Amiro? I have
Keychain, cathode.
Keychain will be your cathode. Anode will
Copper.
be copper. Electrolyte?
Copper solution.
You cannot say copper solution. Apa-apa, copper to sulfate, aqueous. Copper to nitrate, aqueous. Copper to chloride, aqueous. Any one of it. You understand?
Yes.
Yes. Okay. Now, I want to electroplate iron with zinc. I want to galvanize iron. Galvanization is electroplating iron with zinc. So now, Miro, where is your iron? Anode or cathode?
Cathode.
Cathode. Good. Your anode should be?
Zinc.
Zinc. Good. Electrolyte?
Zinc aqueous and
Zinc nitrate, zinc sulfate, zinc chloride, aqueous. Okay? You get the hang of it now?
yes.
Right. So when you want to electroplate, remember anode will corrode, cathode will be deposited. Okay? Now, another one you can do metal purification. Again, they do ask you about metal purification. Say you have impure copper. Say this is brass. Remember, brass is an alloy of copper. Okay, brass is made up of zinc and copper and other metal. You just want to take copper out. Okay, or like you have, sometimes you have, some of these chips, some of these electronic component, they have gold inside, they have precious metal inside. Right, so how do they extract it out? So they do by means of metal purification. Say you have impure copper. Okay, you want to purify it. So now impure copper, this has to be pure copper. Electrolyte has to be apa? What do you think the electrolyte should be? Copper to sulfate aqueous, copper to nitrate aqueous, copper to chloride. So impure copper should be anode or cathode? Someone? Impure copper is anode or cathode?
Pure copper. Pure copper.
Cathode.
It's cathode.
Or cathode? Ina, impure copper is anode or cathode?
Cathode.
Anode.
Should be your
not.
anode.
Anode.
You want the impure to...
Yes, because
Yes.
pure copper will contain, say this is brass. You have zinc, you have copper, you have everything. You just want copper to come out of it. So therefore,
You
what
don't
happens?
want the impurity.
Minus 2 electron to become Cu, right? Will come out here. And then what happened here? Cu 2 plus 2 electron to become 4 copper.
Pure copper.
So this type is silver. If I want to purify my silver, so impure silver will be my anode. Pure silver would be my cathode. Electrolyte has to be silver aqueous. You get that? Yes or no? Everyone?
Yes.
Yeah. So once you understand this, so that's the application. Besides, metal, okay, you can do it for metal purification. You can get it. You can do it. I mean, for electroplating. Okay, everyone understand that? Okay.
Understand.
So recall back what is electrolysis. Electrolysis is apa?
Separating a
Electrical
compound.
energy or using electricity to separate ionic compound into its element.
Ionic compound.
Using
On
electricity. Right. And you have to know how to write the ionic equation at the anode and at the cathode. And you have to know basically in electrolysis is electrical energy changing into chemical energy. You need electricity for your electrolysis. So from now onwards, whenever you nampak je symbol battery, immediately you have to turn it into electrolysis. Okay. And what happened at electrolysis? Anion goes to anode, it releases electron. So meaning that oxidation takes place at the anode. Now electron travels from anode to cathode, and then at the cathode, cation gains electron. Okay, therefore its reduction takes place at the cathode. You okay with that? Yes, no? Everyone okay? Yes?
yep.
Okay, now next one we go into cell. When you talk about cell, just now it's electrolysis. When you talk about cell, cell is about, okay, when you talk about cell, when there's no battery, so straight away treat it as a cell. Because cell is when you have chemical energy changing into electrical energy. So remember that. And those of you who have done, apa nama kita buat hari tu nah? Rusting, right? Okay.
Oh, yeah.
Remember? And we talk about the difference between, they ask you about cathodic protection, the difference between cathodic protection and sacrificial protection.
Yeah.
Now, you have chemical energy to electrical energy. Okay, now you have simple cell or what you call voltaic cell. Okay. Simple cell or voltaic cell. Again, you have to go back to last class we talked about reactivity series. Melissa, do you still remember reactivity series?
Yes.
Yes, give me the reactivity series. Potassium, sodium, gone.
Potassium, sodium.
Because you cannot do voltaic cell, you cannot do Daniel cell if you don't remember your reactivity series. Okay, Carol, do you remember your reactivity series? Remember reactivity series?
I remember.
Remember, okay, give me the reactivity
Yes.
series.
Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, silver. Yeah.
Right, okay, so remember that because without that, you cannot do your voltaic cell. Spend some time to remember, okay, it will not take long. Usually when I do it with the student, it only takes 5 minutes for them to remember. But then they tend to forget if they don't revise. So, okay. Now, when you talk about voltaic cell is when you have two different metals, okay, in an electrolyte. Two different metal in an electrolyte. Remember that. And there's no battery because this is electrical and this is chemical energy into electrical energy. Now, 4 steps, 4 things you have to do. Say I give you zinc, I give you copper, and this can be an electrolyte. Say I give you HCl. Okay. Now, so when you see this, when you see two metal in one electrolyte, so what happened is your first consideration is which one is a more reactive metal. So the one that is more reactive will become the negative terminal. The one that is less reactive will become remember that the more reactive metal will become the negative terminal, the less reactive metal will become the positive terminal. That is very important. Okay. Now next is go back again to the concept of reactivity series. What is reactivity series? It's about tendency of metal.
To lose electron.
Tendency of metal to lose electron. Yeah.
You know zinc is more reactive than copper. Which one has a higher tendency to lose electron? Zinc or copper? Zinc or copper? Zinc or copper? Zinc or copper?
What? Sorry, what?
Which one has a greater tendency to lose electrons, zinc or copper?
Zinc.
Zinc, right. So what happened here?
The zinc will corrode.
Plus. So you see that it corrodes. Zinc gets thinner. The mass of zinc decreases. Anything that indicates zinc and zinc atom undergo
Oxidation.
Now this electron will travel from zinc to copper. So this will make zinc what? Anode or cathode?
This will make zinc the anode.
Anode, because you have to remember, electron always travel from anode to cathode. Ini yang kadang-kadang student kata, teacher saya confused lah, kenapa dia terminal negatif tapi dia anode? Okay, means that you don't understand reactivity series. Okay, if you remember, what do you remember from your electrolysis? Electron always travel from anode to cathode. So you have zinc and copper. Zinc is more reactive than copper. So zinc is a negative terminal. Okay. Copper is a positive terminal. This is the first thing you have to know. Now, the second thing is go back to the concept of reactivity series. The more reactive metal will have a greater tendency to lose electron. Therefore, you know, second, you know that zinc will undergo oxidation. Zinc will release electron to form Zn2+. Zinc atom will be oxidized. The third one, you know that electron always travel from anode to cathode. Since zinc loses electron travel from zinc to copper. Right. Now, at copper, what happened, Balkis?
Yes, teacher.
What happened at copper?
Copper. Oh. Copper undergoes reduction.
Copper undergo reduction. What is reduction? Losing or gaining?
It's gaining electron.
Can copper gain electron? Remember what did I say? Metal never gain electron. Metal loses electron. Can copper gain electron?
No.
No. So
So
what
it's
copper?
copper undergoes oxidation. Yeah.
What is oxidation?
It loses electron.
Look at what happened at zinc. Zinc undergo what?
Oxidation.
Okay, zinc already undergo oxidation. Can copper undergo oxidation? This is a redox reaction. Can copper undergo oxidation as well?
No.
So what happened at copper? Zinc undergo oxidation. If anode undergo oxidation, recall back your electrolysis. Oxidation at the anode, reduction at the cathode. Bakis. Waktu teacher stress banyak kali. Oxidation at the anode, reduction at the cathode. Electron travels from anode to cathode. Oxidation at the anode. So zinc will be oxidized to give you zinc. ions. That is oxidation. So at the cathode will be reduction. So once you understand that, the next question you should ask yourself is, what is there to be reduced? What is there? You have zinc ion, but from HCl, you have your H plus. You have your Cl minus. This is aqueous. You have OH minus. So Amirul, which one will be reduced among these three ions? Nina, which one will be reduced?
The OH minus.
H minus.
Okay.
OH minus, lose or gain, Nina? We're talking about reduction here. What is reduction?
It gains electron.
So which of the ion will gain electron?
The H plus.
The H plus, right? So now what happened at copper? At copper cathode, so you have H plus 2 electron to give you H2. Bubbles of hydrogen here. Get it? Okay, understand? So at the cathode, so this is what happened actually. If you remember these 4 steps, you'll be okay. First is you have to consider which one is more reactive. Zinc is more reactive than copper. So zinc will be negative terminal, copper will be positive terminal. Okay. Now the second consideration is zinc is more reactive than copper. So zinc has a higher tendency to lose electron. Therefore, zinc undergo oxidation. So Zn minus 2 electron to give you Zn2 plus. So that is oxidation. That happened. Now this electron, the electron released by zinc will move from zinc to copper. Hence zinc is the anode, copper is the cathode. Now at the cathode, what happened? Hydrogen ion will be reduced to H2. Is this a redox reaction? Yes, this is a redox reaction. Why is this a redox reaction? Because reduction and oxidation happens
Simultaneously.
Understand? Now, if I give you another one, I give you, okay, one thing you have to know here, okay, remember the 4 steps. Second is you have to remember the further away the two metals are, the bigger the voltage. So this is one way of looking at the reactivity series. Remember when we do reactivity series, you can establish reactivity series in many ways. You can establish reactivity series through by knowing which one react the most with oxygen, hydrogen, or chlorine, or you can see by means of heat decomposition. The more reactive compound or more reactive metal do not decompose. Or you can do it, you can establish reactivity series by means of using voltaic cell. Because the further away the two metals are, the bigger the voltage. So now if they give you zinc and copper, and the question is, how can you make the voltage bigger? Say the voltage reaches 0.8 volt. Now how can you make the voltage bigger than 0.8 volt? What is the concept just now, Melissa? The further the two metals are, the bigger the voltage. Now, this zinc and copper, the cell of zinc and copper give me 0.8 volt. I want a bigger voltage. What should I do? Melissa, what should I do?
Put it further away.
Move what further away? When I say further away the two metals are, doesn't mean that you physically separate them. It's like
Use magnesium.
just now is zinc and copper, right? Now you want a bigger one, you can do zinc, silver, because silver is below copper. Or you can use, you can do calcium and copper. That's what I mean by the further away the two metals are. Get it? So if the question is, how can you get bigger voltage? Replace copper with silver. Or replace zinc with iron.
Magnesium.
Get it? Understand? Yes or no?
Yes.
Yes. Okay, now try again. If I give you silver and I give you lead. Melissa, you like to try? Which one is more active, Melissa?
Lead.
Lead. So lead is more active than silver. Okay, follow my 4 steps. So since lead is more active than silver, which one is the negative terminal?
Lead.
Lead is a negative terminal, silver is a positive. Now, if lead is more reactive, what happened to lead? Which one has a greater tendency to lose electron?
Lead.
Lead. So what happened to lead? What happened?
Undergoes oxidation.
Undergo oxidation. Give me the equation.
Pb
Uh-huh.
plus jap.
What did I tell Balkis just now?
Pb minus
Yes, okay, remember, metal never gain electron, metal lose electron. How many?
2.
Right, so what's your observation? It corrodes, right, lead corrodes, or the mass decreases. Electron travels from Pb to silver. So Pb
Silver.
is what? Anode or cathode?
Anode.
Anode. And silver is
Cathode.
right. Now at the cathode, what happened?
Silver undergoes reduction.
Okay, silver undergo reduction. Can silver be reduced?
Oh no.
No. So what happened? What is to be reduced here? Ask yourself, look again. What is in the electrolyte? H2SO4. Ion apa ada? H plus. SO4 2 minus, OH minus. So which one will be reduced?
H plus.
H plus. So what happened here? You see bubble
2H plus.
hydrogen here. Get it?
Yes.
Yes. Okay. If I replace this zinc and silver, okay, which one is the negative terminal?
Zinc.
Zinc. Which one is positive terminal?
Silver.
Silver. Okay. Now, what happened to zinc?
Undergoes oxidation.
Okay, give me the equation.
Zn minus 2E minus.
Okay, to give you
Zn plus. Zn2 plus.
and 2 plus. Electron travels from?
Anode to cathode.
Yeah, so which one is your?
From zinc to silver.
Yes, so zinc is your anode, silver is your cathode. Now, at the cathode, what happened?
Hydrogen undergoes reduction.
Or hydrogen ion.
Yes. Hydrogen ion.
Hydrogen ion undergo
Reduction.
reduction. Right, reduction. So you see bubbles of hydrogen.
Hydrogen.
Okay, you okay with that?
Yes.
Yes. Okay, good. Okay, now. So once you understand that, okay. Now, next one would be your sama juga. So tadi apa? We talk about cell. Cell is what from what? From what energy to what form of energy? From electrical energy to chemical energy. And what you have to remember with simple cell and voltaic cell, we have two metal in its aqueous solution. The more reactive metal will become the negative terminal, the less reactive metal is a positive terminal. So the more reactive metal will undergo oxidation, and then it will corrode. And then electron travel from the more reactive metal to the less reactive metal, and then at the less reactive metal at the cathode, it depends on what you have in solution. Okay, will be reduction. Okay, and the further away the two metals are in the reactivity series, the bigger will be the voltage. Okay, another one will be your Daniell cell. Right. Okay, Daniell cell is the same as your voltaic cell. You have Tadi you have zinc and copper, right? Now you have metal in its aqueous solution. So you have zinc and copper. So this is zinc nitrate. This is copper
What is it? Oh,
nitrate. Right, and then you have this, okay? You have your salt bridge. Okay, salt bridge will allow movement of ions, okay? Remember, electron travels on the outer line. Salt bridge, ions will travel through the salt bridge. So now the same consideration, or this thing can also be done by means of, you use a big tank and then use a porous pot, and then this would be copper, this would be zinc, zinc nitrate, zinc nitrate, copper in copper 2 nitrate. Right, same thing. This is porous pot. So this porous pot will allow for movement of ions. It's the same thing. Now the same consideration as before. Zinc is more reactive. Which one is the negative terminal again?
zinc.
The negative terminal. Right. Okay, zinc would be the negative terminal, copper would be the positive terminal. Now, since zinc is more reactive, what happened at zinc? What happened at zinc?
Zinc will be discharged. It loses electron. 2
What
electrons.
happened to zinc?
Zinc loses 2 electrons.
Zinc atom will be oxidized to zinc ion. Right, so you notice zinc will corrode. Electron travels from zinc to copper. Zinc is anode, copper is cathode. Right, so electron travels. Now at the cathode, same as before, what happened? Okay, not same as before, but here at the cathode, you have metal in its aqueous solution. Okay, metal in its aqueous solution. Okay, what do you remember when you have metal in its aqueous solution? Anode will, apa tadi? Anode will what?
Cannot corrupt cathode deposit.
Yeah, so what happened here instead? So you have Cu 2 plus 2 electron to become copper. So you notice copper will be deposited here. Get it?
Yep.
Right, okay. Now if I change this to, you can change anything. Say I give you silver, I give you lead and silver, right? So this will be lead to become Pb2 plus, and then here it should be Ag plus electron to give you Ag. You okay with that? Yes? Understand? Amirul, are you okay? Yes or no?
No.
No. Which one? You have to let me know.
Teacher cepat sangat. Cannot
Yeah.
catch up.
Yeah, which part? Which part? You have to mention to me. You have to tell me. Yang tadi tu you faham tak? When you have metal, when you have two metal in an aqueous solution, you faham tak? Metal in an
Yes.
electrolyte. You faham kan?
Mm.
Remember the 4 things that you have to consider? First consideration, which one is more reactive? The more reactive is the negative terminal, the less reactive will be the positive terminal, right?
Yeah.
Okay, and the concept of the more reactive the metal is, the higher the tendency to lose electron. So if you have zinc and copper, zinc will lose electron to give you zinc, and 2 plus, zinc undergo oxidation. Electron travels from zinc to copper. So at copper, since zinc undergo oxidation, at the cathode there must be a reduction. So you look at the equation, you look at the solution, you have hydrochloric acid. So hydrogen will be reduced to hydrogen gas, right? What do you understand?
Yes.
How many?
Yes.
Yes, okay. Now when you do your Daniell cell, it's the same thing, except that you have metal in its aqueous solution. Zinc in zinc nitrate, aqueous. copper in copper nitrate aqueous. Okay. Now, from your cell just now, you know the more reactive metal will become the negative terminal.
Mm.
The less reactive metal will become the positive terminal. So zinc is a negative terminal, copper is a positive terminal. Now, zinc and copper, which one has a higher tendency to lose electron?
Copper.
Okay, remember the concept. The more reactive the metal is, the higher the tendency to lose electron. No, like those, if you have been with me for long, you know that chemistry is easy because there's a few concepts you have to remember. The more reactive the metal is, the higher the tendency to lose electron. So now you know zinc is more reactive than copper. So zinc and copper, which one has a higher tendency to lose electron?
Zinc.
Zinc, because the concept is the more reactive the metal is, the higher the tendency to lose electron. So what happened at zinc is zinc loses electron to become zinc ion, right? To become Zn2+, right? So this electron will travel from zinc to copper. Sama macam cell tadi. So zinc will be anode, copper will be cathode. How do you know? Because electron always travel from anode to cathode. So if electron travel from zinc to copper, so zinc must be anode, copper must be cathode. That one, you clear?
Yes.
Yeah. Okay, now here, when you look at copper, it's slightly different from the cell just now. Cell tadi, you ada 2 electrodes, 1 electrolyte. But here you have 2 metal in one. So copper in copper to nitrate. You get that? Copper in copper to nitrate. So now when you have metal in its aqueous solution, apa tadi you kena ingat? Anode will corrode, cathode will be deposited. So now copper is the cathode. So what happened here? Copper ion will be reduced to copper. So you see brown deposit of copper. Understand?
Yes.
Yes. Okay. You can replace this with anything. You can play with this. Okay. You can either do it like this or you can put it in. Right. You can replace this with something else. Just play around with it. This can be lead, and then this can be silver. Anything. But provided you know your reactivity series. If you know your reactivity series, then you do. Okay. So now here, you can replace. Here, you have lead, so this can be lead nitrate. Silver, this can be silver nitrate, aqueous. Right, okay. Now play with me now, mirror. Which one is more reactive, lead or silver?
Reactive.
Which one is more reactive, lead or silver?
Lead.
Lead. So lead is more reactive than silver. So which one is the negative terminal?
Silver.
What is the key point you have to remember? The more reactive metal become the negative terminal. Remember the 4 things. First consideration, which one is more reactive? The more reactive becomes the negative terminal. So which one is the negative terminal?
Lead.
Lead. Which one positive? Silver. Now, next consideration you have to remember. Next concept. The more reactive the metal is, the higher the tendency to lose electron. So given a choice between lead and silver, which one has a higher tendency to lose electron?
Lead.
Lead. So what happened here? Pb minus 2 electron to become Pb2+. So lead atom will be oxidized to lead ions. So what's your observation? You notice that your lead will corrode. Okay. Now this electron will travel from lead to silver. Recall back your electrolysis. Electron always travel from anode to cathode. So lead is your anode, silver is your cathode. Right. Now next one, what happened at the silver electrode? Silver electrode is cathode, is in the aqueous solution of silver. Okay, remember when you have metal in this aqueous solution, what happened? Anode, corrode, cathode will be deposited. So what happened here? Silver ion gain electron to become silver. So you see gray deposit of silver. You okay with that? Yes?
Yes.
Yes. Understand? Play
Yes.
around with this. You know your reactivity series you can replace with anything, provided it's metal in its aqueous solution. Okay? Right. Okay. So everyone okay with this? Yes? Any question? Question?
Yeah, okay, teacher.
Marisa, you okay?
Yes.
Yes. Okay. Take okay. Amar give you the paper, right? Open up the paper now. Okay, here. This one is from the previous one. Okay, here. Page 2. In the first page, you can do it as a revision for your last week. Okay, now page 2. Now, copper to sulfate solution was electrolyzed using the apparatus shown. You have carbon cathode and you have carbon anode. You have solution. Draw an arrow on the diagram to show direction of movement of electron in the wire level the way is. Okay, now, Amirul, what happened here? Copper to sulfate, what ions are present? Whenever you do electrolysis, always list down the ions. What ions are present? Amirul, what
Iron.
are present?
Co Copper. Copper.
Remember, this is copper to sulfate plus SO minus. This is a solution, means plus and OH minus. Now, before you do anything, make a habit of doing this first. List down all the ions present. So now, which one goes to your anode? Which one goes to your
Anode. Copper.
anode is the negative, anode is a positive terminal. So which one?
Sulfur.
Sulfate. This is sulfate.
Sulfate.
2 will go to your
Anode.
Okay, remember anode is a positive terminal. Which one will go to your cathode?
Copper.
Copper 2 and hydrogen. Now, at the anode, you have your sulfate and hydroxide. Which one will be chosen? Which one will be chosen, Amiro?
Yes.
Which one will be chosen, sulfate or hydroxide?
Hydroxide.
Hydroxide because hydroxide is less reactive than sulfate.
Sulfate.
Okay, so what happened at your anode? You have 4 OH minus 4 electron to give you 2 H2O plus O2. So you get bubbles of oxygen. Now, at the cathode, you have copper ion and hydrogen ion. Which one will be discharged?
Wait. Sure.
Copper or hydrogen?
Discharge.
Yeah, which one will be discharged?
Oh, hydrogen.
Why hydrogen?
Less reactive.
Okay, seriously, take it when I say you have to go back, remember your reactivity series. You tak boleh buat reactivity series, you tak boleh buat ni. Because if you remember your reactivity series, hydrogen is more reactive than copper. Okay, hydrogen is more reactive than copper. So which one will be chosen? It will be copper. Okay. You don't want to lose marks just because you don't remember your reactivity series. Because reactivity series, no one can do it except for you. You have to remember it. Okay. And find ways to remember it. Remember, kalau nak kahwin mesti ada zakat fitrah supaya perkahwinan kekal abadi. This is what my friend told her student. Okay, you can do your own. Like, you know, every maktab have their own. Like I remember Kota Putra, Kamal naik camel, minum air zam-zam, whatever. You can come up with your own mnemonic so long as you remember, because you have no choice but to remember. Otherwise, you know, you find most students, what I notice is that most students will find redox and electrolysis difficult. But it's not difficult, it's just that they don't remember the reactivity series and they cannot do their ionic equation. So now you have copper. So here at the cathode, you have brown deposit of copper, and know that copper is brown, other metal is silver. Okay, and at the anode you have bubbles of oxygen. Now what happened to the color of the solution, Amirah? What happened to the color of the solution? What color is copper 2 sulfate? Anything with
Brown.
C plus. Any copper solid is brown. Copper 2 aqueous would be anything. Anytime you nampak copper 2 aqueous, it will be blue. Okay, blue because of the presence of copper 2 ion. Now, what happened to the copper 2 ion? It has been discharged. It has been reduced to copper. So now the number of copper ions decreases in the solution. So the solution change color from
Blue.
colorless. Okay, so those are the observation. You do this one first, then only you answer the question. Now, so copper gains electron. Now here OH minus loses electron. So here electron travels from anode to cathode. Right, draw an arrow on the diagram to show direction of movement of electron in the wire. Label the arrow A. So this is A. Now draw an arrow on the diagram to show direction of movement of positive ion in the copper to sulfate solution. So where is it? From where to where?
Anode to cathode.
No. Arrow to show direction of movement of positive ion. Positive ion goes to anode or cathode? The positive ion, it goes to anode or cathode?
Positive ion go to cathode.
Cathode. So label this. This is P. Now oxygen was formed at the anode and copper was formed at the cathode. I need half equation for the formation of oxygen is shown. 4OH minus to give you O2 plus. Remember I mentioned last class, minus 4 electron or plus 4 electron. In O level, it's okay. You can put minus on this side or you can put on the right side. It's okay. Now, why this reaction is oxidation, Nina?
The hydroxide loses its electron.
Because you have oil rate, right? Oxidation is losing of electron. Write and half an equation for the formation of copper at the cathode, Nina. Copper at the cathode, it should be
Sorry. The Cu2 plus would lose to electron to form copper metal.
Right, okay. Electrolysis was repeated using copper electrode in place of carbon electrode. Then explain what happened to the mass of the anode and the cathode during electrolysis. So now you use copper in copper to sulfate. Apa you?
The anode will corrode and the cathode will deposit it.
Okay, so now what happened to the mass of the anode?
The mass of anode will decrease and the mass of cathode will increase.
Very good. Why?
Because at the anode, copper ion is undergoes oxidation to form copper metal and
Undergo oxidation.
oxidation.
Yeah. And the cathode, copper ion undergo
Reduction.
Right. Okay. Right. So here state and explain. State what happened to the mass of the anode. Mass of anode increase. So you mentioned mass of anode increases. Anode Increases pula. Decrease.
Increases.
And okay, kenapa decreases? Explain. Because okay,
Copper metal
copper atom
undergoes oxidation
oxidized to
to form copper ion.
electron to form two plus. Right. Or copper ion, copper atom undergo oxidation. Now, mass of cathode
Increases.
increases. Okay, now explain.
Copper ion undergoes reduction by gaining 2 electrons to form copper metal. Hence, copper metal is deposited at the cathode.
Copper atom, which are deposited.
At the cathode.
Right, that's 4 marks for you. Okay? Everyone? Melissa, okay?
Yes.
Yes. Okay. Now, copper has a structure. Okay, this one we discussed already last time. Now, okay, here. Page 4. Cell reaction are both exothermic and redox. They produce electrical energy as well as heat energy. Okay, they produce electrical energy and they produce heat energy, so they are exothermic. Right. Diagram shows a simple cell. You have zinc and iron. And then it becomes thinner bubbles of hydrogen. Okay, before you do anything, again, analyze it. Which one is more reactive, zinc or iron? Melissa?
Zinc.
Zinc is more reactive than iron. So which one has a greater, so zinc is more reactive than iron. Which one is a negative terminal, Melissa?
Zinc.
Zinc is a negative terminal, iron is a positive terminal. Now, which one has a greater tendency to lose electron?
Zinc.
Zinc, right. Okay, so Zn minus 2 electron to become Zn2 plus. So what do you think your observation will be? Melissa? So what happened to the zinc electrode? Zinc electrode get thinner. The mass of it
Thinner.
increases. Right. Now electron travels from zinc to iron. So which one is your anode?
Zinc.
Zinc is your anode. Good. And iron will be your cathode. At the cathode, what happened, Melissa? Which one will be reduced? Remember this
Hydrogen will be reduced.
hydrogen ion will be reduced. Right. Right. So therefore you have bubbles of hydrogen. This cell is a reductant. So recall back, so you have Zn minus 2 electron to become Zn2 plus, and then you have 2H plus 2 electron to become H2. Remember last class we did your ionic equation, 2 electron release, 2 electron gain, cancel off, you end up with Zn plus 2H plus to give you Zn2 plus H2. Okay, zinc undergo
Oxidation. It is a reductant.
reductant or reducing agent. Right, hydrogen ion undergo
Reduction itself
Reduction.
is an oxidant.
It's an oxidant.
oxidant. Right, you okay with this?
Yes.
Now, which substance
Yes.
in the cell is the reductant? Reductant is
Zinc.
zinc atom.
Atom.
Right, what is the oxidant? What is the
Hydrogen atom.
Hydrogen.
hydrogen ion?
Ion. Sorry.
Be careful with that. Okay, be careful with that. Kadang-kadang you lose marks just because you silap.
Yeah.
How could the voltage of this increase?
Replace
Replace zinc with
zinc with aluminium.
Replace zinc with aluminium or replace iron with silver.
iron with silver.
Anything, you just use one. What is the important large scale relating to iron and steel of this type of reaction? What kind of important scale? What is this? I mean, in our case, you have done this before.
Yes, teacher.
What is the important large scale used relating to iron and steel of this type of cell reaction?
Iron and steel.
Yeah. What is the large scale application of it?
Oh, galvanization.
Galvanization, I mean.
Huh?
Galvanization. Or sacrificial protection.
Oh, wait. Oh, wait. Large scale, yes, sacrificial protection.
Right. Sacrificial protection. Yes, if you say galvanization, steel is acceptable. Okay. Now, cells can be set up with inert electrodes and electrolytes as oxidant and reductant. You have carbon electrode, inert carbon electrode. You have potassium manganate, potassium iodide, carbon electrode. So you use carbon electrodes instead. Steel is a Daniell cell. Now you have the salt bridge. But what happened here? What's taking place here? Kalau you tak tahu, what strikes you? Read again. You have apa ni?
The
Potassium
potassium
manganate.
manganate 7.
Come across potassium manganate, you come across potassium dichromate, they are what?
Gas reductant.
Oxygen.
Oxidant.
Okay.
Oxidizing.
Okay. How do you change alcohol to carboxylic acid dulu? Remember? You use dichromate, right? So whenever you see dichromate, you see potassium manganate is an oxidizing agent. Potassium manganate, what color will it be? Purple. Yes, it turned from purple to colorless. Right. So at least start with that. Start with what you know. Right. You biasa metal in its aqueous solution, but now they give you both have carbon electrode, but one have potassium manganate, another potassium iodide. So you know, ask yourself, what do I know? I know that potassium manganate is an oxidant. It will change purple to colorless. Right. Now then it says here electron flow is from the iodide into the manganate. So electron flow is his. This one should be the anode, this one should be the cathode. What else do I know? I know that anode, there will always be anode. At the anode, there will be oxidation. At the cathode, there will be reduction. Remember that? Ingat tak?
Yes.
At the anode will always be oxidation. So what is to be oxidized? That's the question you should ask yourself. Look at what's in the beaker. You have potassium iodide. So potassium iodide is I minus. So it should be, remember, anode is oxidation. It should be oxidized to what?
Iodine.
Iodine. So therefore, losing or gaining or electron,
Losing electron.
right?
Oh.
So therefore, that's why electron travels here. Okay. So is this oxidation or reduction? This is oxidation.
Oxidation.
Right. Does it go with what I understand? Or with what the facts that I know is at an anode, there will always be oxidation. So iodide will be oxidized to iodine. Now, next question you should ask yourself, iodine in an aqueous solution, what color will it be? Solid iodine is purple. Iodine in aqueous solution, what color will it be?
Iodine in colorless.
Will be yellowish brown. Remember, you test for starch, right? Yellow brown,
Oh, yeah.
right? Now, iodide, potassium. Potassium is group 1. Group 1, no color. So, potassium iodide is colorless.
Colorless.
Therefore, what is the observation? It changed, the solution changed from colorless to brown. Why? Because iodide is oxidized to iodine. Electron travels from anode to cathode. At the cathode, what happened? This is potassium manganate 7. So Mn 7 plus will change into Mn 2 plus. It gains electrons, so this is
Reduction.
You get that?
Yes.
Once you
Yes.
understand that, then only you start doing it. Potassium manganate 7 is the oxidant, potassium iodide is the reductant. Color change that you observe on the left hand beaker. What's the answer?
Purple to colorless.
Purple to colorless. Ionic equation for the right hand beaker. Now can you do it?
Yes.
Yes. But initially, can you do it? Can you, Nina?
Ha?
Ha?
Saya pernah tanya soalan sama.
Kan? Dia pernah tanya.
Sama.
Ingat lagi tak?
Saya pun.
Yes.
I remember that time.
Yeah, right. So you have to think along that way. Okay. Kalau tak, you tak. Okay. Okay, you try finish up as much as possible. And then if you need more, you know, you have a lot in from your passive paper, you have a lot there. Okay. Now, just one more, last one, a quick one. You have chemical reaction always happening by energy change, aluminum is which contain aluminum oxide, this decomposition is decomposed to form aluminum negative electron. I need electrolysis at the negative electron. Marisa, what's your answer? This is electrolysis of aluminum oxide, molten aluminum oxide.
Okay. So,
What's your answer? Are you there?
Melissa?
Lisa.
Yes.
Yes. Equation at the negative electrode when you do electrolysis of aluminum oxide. We did it last class. Can you not? If you cannot do it, I'll help you. Can you or can you not?
I can.
You can. Cannot.
Cannot.
Cannot. Ask yourself. This is molten aluminum oxide. What ions do you have?
Aluminium.
Aluminium.
Okay, now this is negative electrode. So which one goes to negative electrode?
The positive ion.
Which is
Positive ion.
aluminum. So what
Ion.
happens here? Al3 plus. Remember, plus electron to give you aluminum. So, and some more, negative electrode is the cathode. Anode will be oxidation. Cathode will be reduction. What is being reduced? Aluminum ion will be reduced. Get it? So you have to ask yourself, what do I know? This is negative electrode. This is molten. So ask yourself, what is in molten? Al3 plus, O2 minus. Next, this is negative electrode. Remember back, at the positive electrode, at the anode is oxidation. At the cathode is reduction. So of these two ions, which one will be reduced? Ingat. That's how you process it, okay? Now, complete the ionic equation at the positive electrode. So positive electrode, 2O2 minus apa? O2 plus H2, right,
H2.
plus 4 electron. Is the reaction exothermic or endothermic? Exothermic or endothermic? Is electrolysis exothermic or endothermic?
Exothermic.
Exothermic.
Right. Why exothermic?
It
Releases
releases
energy.
Releases? Releases apa, Balkis?
Energy.
Energy. So if it's exothermic, what can you say about the bond forming? Nina and Amin, you should be able to answer me.
The bond form is greater than the bond
and
broken.
breaking.
Stronger. Strong bonds are being
Strong bonds are being formed.
okay. Anyway, the rest of it is okay. That one later on you do. The cell chain below can be used to determine the order of reactivity of metal. Here you have magnesium and magnesium electrode, copper electrode, magnesium sulfate, porous barrier. So is the reaction exothermic or endothermic? The answer is? Whenever you have cell, whenever you have electrolysis, it's an
Exothermic.
Exothermic.
Why do you say exothermic? Because it releases heat energy. energy.
Energy.
Now explain why mass of magnesium decreases, mass of copper increases. Okay, why
Mag-
magnesium decreases?
Magnesium
Because
is
the
the
magnesium
is a negative
corrodes.
It loses
electron and it
electron.
oxidizes.
Yeah, it loses electron.
Okay, how do you this? Right, because magnesium is more reactive than copper. Magnesium is negative terminal, copper positive terminal. Magnesium is more reactive than copper. Magnesium has a higher tendency to lose electrons. So what happened here? Mg minus 2 electron to become
Mg2+.
Mg2 plus.
electron troubles here. What happened here? Cu 2 plus
Cu2+.
become
Plus 2 E giving
CO.
CO.
deposit of copper. Okay.
Mm.
Now, how could you use this cell to determine which is more reactive metal, magnesium or manganese? What do you do? How could you use this cell to determine which is the more reactive metal, magnesium or manganese? How could you do? What do you do, Nina?
Oh.
Replace magnesium,
With manganese.
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 the voltage. Okay, the more reactive metal will have a higher voltage.
Higher voltage.
Higher voltage.
Concept do you have to remember? The
The
more
further apart.
The more reactive the metal, the higher the dose.
The further apart they are from the reactivity series.
The higher the voltage.
you understand that?
Yes.
Right. Okay.
Yes.